All right, chapter 4. Remember, in chapter 1, we started with linear equations. With their functions, their structures, their graphs. Then in chapter 2 and chapter 3, we start talking about quadratic equations. And chapter 3. So, and what we learned by looking at these functions that the leading terms, the degree tells us how many solutions we're going to have, what the graph looks like. We know this one's going to be a parabola, depending on what A is. If A is positive, it's up. If A is negative, it goes down. This is linear. If X is positive, if M is positive, it goes up. If M is negative, it goes down. Reading left to right. So that's all that sort of stuff we're looking at. But now in chapter 4, a polynomial equation. Poly means many. Nomial means numbers or terms. Polynomial simply means it has many terms. Yeah. Polynomials can be monomial. Only one term. Or why it could be a constant. It could be a binomial. Has two terms. It could be a trinomial. And so on and so forth. Quadrinomial will have, quad means four. It'll have four terms. And we keep on going. Anything higher than this, we say it's an nth order polynomial. Polynomial. Which actually look like this. It'll be a polynomial. You'll have a leading term. Since it's an nth order, that's that degree. The next one, well, let's leave it A's. And this is n, this is n minus 1. N minus 2. All the way down to AX at A. where this is sub 1, and that's 0. That's a polynomial. Again, the leading term is the first term in the whole list. Has the largest exponent, which is called the degree. Which is also called, as we just saw, the order. Now, when I talk about order, this is a fourth order polynomial, which means we're going to have 4 terms. So since it's a fourth order, n minus 1 equals the degree. Binomial, bi means 2. The degree is 2 minus 1 is 1. It's a linear equation. Trinomial, tri is 3. 3 minus 1 is 2. The largest exponent is 2. And so on and so forth. All right. So of the leading term, we have the leading coefficient. Which is the A value. Again, that tells us if A is positive, it goes up. If the leading coefficient is negative, it goes down. Actually, it goes a little bit more to it than that. Because now we have a lot more to look at, depending on the degree. From our library of functions, if we had x to the power 2, the graph would look like that. If x was to the power 4, it would look something like this. If it's to the power 6, it would look something like this. What if it was a degree 1, it would look like this. Degree 3, and degree 5, and we'll see a pattern here. The degree it also tells us the maximum number of solutions possible. Remember, solutions are what we call x-intercepts also. So the squared equation, at most, we can cross it twice. X to the fourth, 1, 2, 3, 4. X to the sixth will have at most 6 intercepts. If we just had an X, then it's only 1 time. X cubed is maximum 3 times. X to the fifth is 5 times. So that's what tells us. Now, we just said it's the maximum number. Let's say we had an equation that looks like this. X to the fourth. The graph, the possibilities of the graph, it can look like this. It can look like this. We have 4 solutions. Or we can have 1, 2, 3 solutions. We can have 2 solutions. We can have 1 solution. Or we can have no solutions. I should say real solutions. Or another example, let's look at if y equals x cubed. It can look like this, or 3 solutions, 3. It can look like this, where we have 2 solutions, or 1 solution. Obvious now, what should be apparent is depending on the degree, it tells us, yeah, that we have maximum 4 and maximum 3, but the minimum number, if it's an even exponent, if it's an even degree, you can have no real solutions because both ends point the same direction. In an odd degree, both ends point different directions. So you have to have at least 1 solution and at most n solutions. So even degrees, you have to have, or you can have n solutions, or you can have 0 real solutions. With odd degrees, you have to have at least 1. But more so, we call this end behavior. End behavior. If the degree is even, Both ends point the same direction. If the degree is odd, the end behavior is they point opposite directions. We don't know what happens in the middle, but we know at the end of the graph, even have to point in the same direction, odds, opposite directions. So we have a chart that we can do to help us. N is even, N is odd. Our leading term looks like this. That's our leading term. If A is even, positive, or A is negative. If A is positive, even degrees, they point up. If A is negative, even degrees point down. If A is positive, the function is increasing, because as we read left to right, the graph is always going up. If A is negative, the graph goes like that. So that's going to help us. We know what the graph's going to look like now. And yes, we've been looking at polynomial functions all along with the library of functions. All right, let's look at examples here. This is called the leading term test. Here's example 1. Use the leading term test, which is that, to match the following. Here are the functions. A, y is equal to 3x to the 4th minus 2x cubed plus 3. B, g of x is negative 5x cubed minus x squared plus 4x plus 2. Y is equal to x to the 5th plus 1/4 x plus 1. Negative x to the sixth plus x to the fifth minus 4x cubed. And here are our 4 possible graphs. So that's capital A, capital B, capital C, and capital D. Okay, so let's look at these things. We have to look at 2 things. Let's look at the leading term. So make sure with all these numbers, look at the highest exponent. That's the leading term. First, there's A. It's positive. So it means it's going to be going increasing function, so it's always going to be going up. X to the fourth. It tells us here the degree is even, so that means both ends point the same direction, and it's going up since A is positive. So which one of these do they both go the same direction and both up? So it's D. That's it. That goes to A. Look at B. X cubed. The degree is odd, so the ends go opposite directions. And it's negative, so it goes opposite directions down. Ooh. If, let's see which ones other ones we have. Okay, this one's going up. It's different directions, so it's an odd degree, and it's positive. So this one's A belongs to C because it's an odd degree, means opposite ends, and A is +1. So it's increasing. Now we have to worry about B and C. These two, they're both negatives, so they're pointing down. But our degrees, this one's odd, this one's even. If it's even, they both point the same direction. They both point the same direction, and they're down, so this one must be C. Since this one's odd, they point different directions, and it's pointing down, so this one must be B. So this is kind of stuff that once we start looking at these, then we can start breaking them down and know what they're supposed to look like. All right, so let's look at now. Remember, we've been talking about, well, let's just go over the words again. We talk about solutions, zeros, and intercepts. They all mean the same things. Pretty much where the graph crosses the x-axis. Solutions, intercepts. Remember, this is the intercept is an x-intercept. This is a location. The zero is what x value will make the equation equal to 0. So we're looking for an x value. And when we talk about solutions, we're also looking for what what are the numbers that make them equal 0 or whatever we're looking for. Typically, when we're looking for solutions, we set y equals 0 and solve for x. Because the way you represent the answer is endemic to what kind of equation you're looking for, what kind of solution you're looking for. Example 2. Consider this polynomial. Squared minus 17x plus 15. Determine whether each number determine if 2 and -5 are zeros of our polynomial. So these are x values. What we're looking for is p of 2 and then p of -5. If they're zeros, then it'll equal 0. So let's see this. We have 2 to the power 3 plus 2 to the power 2, 17 times 2 plus 15. 2 to the power 3. 2 times 2 is 4 times 2 is 8. 2 squared is 4. 17 times 2 is 34 plus 15. 8 plus 4 is 12. Minus 34 plus 15. 12 plus 15 is 27. 34 is bigger, it's negative. 34 minus 27 is -7. So no. 2 is not a 0 of p of x. -5 cubed plus -5 squared. 17 times -5 plus 15. -5 times negative times negative is always just be negative. Negative times negative is negative. So 5 times 5 is 25. 25 times 5 is 125. So it's negative 125. -5 squared makes it a positive. This makes it positive 25. Negative times negative is a positive. 17 times 5 is 35. It makes it 85 plus 15. Negative 125 plus 25 is negative 100. And then these two are positives. 85 plus 15 is 100. So yes, -5 is a 0 of the polynomial p of x. Okay, we know what the graph's going to look like. It's a cubic function. It's positive, so the graph will look like this. Or it'll look like this. It's an increasing function, but we know that -5, we have an intercept. Example, find the zeros. F of x equals 5x minus 2, x minus 2, x minus 2, x plus 1. So to find zeros, since this is factored already, we'd set each one of these equal to 0. So we get x equals 2, x equals 2, x equals 2, x equals -1. So our zeros are at -1 and 2. Those are my zeros. But now here, now we get something very interesting about these type of equations, because we could have rewritten this equation we could have made it much shorter. There's the 5. We notice we have 3 of those. So we could have just made it to the power 3. And then x plus 1. So if you have the same factors, we just put them under there. And that's going to help us graph it also. Just to show you, we'll talk about these in a second. All right, example 4. Find the zeros. We have x negative x minus 1, x minus 1, x plus 2, x plus 2. So these are already factored, so the zeros are going to be at +1, +1, -2, -2. So my zeros are at -2 and 1. Those are my intercepts. Let's look at both of those equations, because it's easy to graph these. Well, easier. So the first example we had, this is from example 3. This one's from example 4. Remember, once we simplified it, we had x minus 2 cubed, x plus 1, and example 4, here, we could have rewritten this one. Since we have two of the same, we could have done x minus 1 squared, x plus 2 squared, and negative out in front. So if we were to graph these, what would they look like? So what's the degree? Now, whenever we have multiple of these zeros, the degree is equal to the sum of all exponents. So the degree of this equation is 3 plus 1. So the degree is 4. A is the leading coefficient, which is 5, which is positive. So remember what that means? If the degree is even, they both point the same direction. In this one, they both point up. But we only had two solutions here at x equals 2 and x equals negative 1. So this graph, well, it looks like something like this. Because they have to, because it's even, they have to point the same direction. They have to point up since the coefficient a is positive. But we only have two x-intercepts, two solutions. How do we know that? Well, we plot our 2 points here, pick some points along the line, plot them, and we have our graph. What about this one? What's the degree? Two plus 2 equals 4. But a is negative 1. So the degree is even. So they both point the same direction. They both point down. Yeah, they both point down. And our solutions are at 1 and negative 2. So at these 2 points, only thing we know is that the two intercepts, the graph has to be going down. That's all we really know for sure. Plotting some points, we'll see that we get this kind of graph. Our intercepts are at 2, negative 1. Those are the only points we have. Both ends have to go the same direction. These things have names. These, when you combine them like this, condense a polynomial, these are now called multiplicity. So what we say here is this. Our solution x equals 1, multiplicity of 2. What that means, it tells us that this answer occurs 2 times. And the second one is x equals -2 with a multiplicity of 2. This is another one. They give you a shortcut on how we tell the graphs what they look like. So here's example 6. 5, I'm sorry. Find the zeros. So f of x equals x cubed minus 2x squared minus 9x plus 18. We've talked about linear equations, quadratic equations, with 2 and 3 terms, but what if we have 4 terms? If we have 4 or more terms, so we have 4 terms. Then we use a method called grouping. Then use grouping if possible. Okay, now what grouping tells us, if we have 4 terms. If we have 4 terms, yes, check. So what we do here is we put parentheses around the first terms. If the middle term is minus, then include it in the parenthesis. And put the second ones in parentheses. If it's a plus, then we would leave the plus outside the parenthesis. So since this one is a minus, it's included inside the parenthesis. Okay, so that's first step. Second step, what can we factor out of both of these? In the first one, they both have an x squared. If I take out 2 x's here, I just have 1 more x. Minus, I took away 2 x's, so all I have left is 2. Now in the second one, since the leading term is negative, we got to factor out the negative, which means we got to change their signs inside the parentheses. They both have a 9 in common. So since we factor out a -9, to see what goes inside here, we divide both of these by -9. Negative and negative cancel, 9's cancel, so all I have is an x. Positive divided by a negative is negative. 18 divided by 9 is 2. So this is what we're hoping for in this method. You notice inside the parentheses, they're exactly the same numbers. But remember, we only have, if you look at this, we only have 2 terms, and they both have the x minus 2 in common. So I can factor out the x minus 2 out of both of these. What I'm left with are these coefficients. X squared minus 9. We have x minus 2. This is a difference of two squares. It's x squared minus 3 squared. So it's x plus 3, x minus 3. So my zeros are at positive 2, negative 3, positive 3. Those are my zeros. If we look at a graph, we have negative 3, positive 2, positive 3. Those are my intercepts. Those are my zeros. It's an odd function, so they point opposite directions. Leading coefficient is a positive 1, so they're opposite directions. This end goes down, this end goes up. So our graph will look something like this. And we know we have a y-intercept of 18. We can pretty much sketch the graph real quick, what it's going to look like. All right, let's look at examples. Find the zeros. X to the 4th plus 4x squared minus 45. So we have to factor this one out. It's 3 terms, so it's a trinomial. Trinomials, we can see, are they quadratic? Are they quadratic in form? Remember, look at the middle term. Take the middle term. If we multiply it by 2, and we get the first term, the degree of it, then it's quadratic in form. That means we can use either factoring, complete the square, or the quadratic formula. So for this one, let's go ahead and factor, because I'm seeing that it would work. Okay, I don't know that. Remember, you always solve for the middle variable. So it's going to be x squared. The second sign is a minus. So that means they're opposite signs. And since it's a minus in the second sign, look at the first sign. It tells us that the bigger number will go in the positive. So what times what equals 45? That when we subtract them, we get 4. 9 times 5, 9 minus 5. So the bigger number gets the positive. No. We're supposed to have at most 4 solutions. So now we take both of these equations and set them equal to 0, because we're looking for the zeros. So subtract 9 from both sides in this first one. We have x squared equals -9. To get 9, we have to square root both sides. I have to get the x by itself, I mean. Remember, whenever you square root something that's squared, you got to put a plus or minus in front of the answer. So the square and the square root cancel. Equals plus or minus. Well, we have a negative inside the square root, so that becomes an I. Square root of 9 is 3. So we have two imaginary numbers. And remember, imaginary numbers always come in pairs. So that was our first one. Now the second one. Add 4 to both sides. X squared equals +4. Square root both sides. I have to put a plus or minus on this side because I'm square rooting something that's squared. Those cancel, so I have x equals +or -2. And those are our solutions. So we can use any of the methods we've discussed in the past just to simplify and solve these. All right, we'll go ahead and stop there, and then we'll pick up next week. Hi, everybody. Have a great weekend.